Hari Om. In the fifth module of the microprocessor course, we are currently discussing the input-output interface units, in which we have discussed the three data transfer schemes: programmable input-output, interrupt-driven input-output, and the DMA. After discussing the three data transfer schemes, we discussed 8257A, which is a DMA controller. The architecture and features of 8257A we discussed in our previous video. Also, we have discussed the programmable interrupt controller 8259A, which is used for managing the interrupt driven input output. Now, to manage the programmable programmed input output data transfer scheme, we have programmable peripheral interface 8255. So in this video, we are going to discuss the pin description of 8255. 8255 is a general purpose programmable input output device designed by Intel for the use with Intel microprocessors. It is also called as programmable peripheral interface, and it is also known as programmable peripheral input output port. And this interface is a parallel input output port chip, and it can be used with Intel's 8-bit, 16-bit and higher capability microprocessors also. So if you want to implement programmable input output data transfer scheme, then we can use 8255 PPI. And 8255 is designed to interface the CPU with the devices such as analog to digital converter or digital to analog converter or even keyboard. So these are the kind of devices which can be implemented using programmed input output data transfer scheme. So to interface these kind of devices, we can make use of 8255. And 8255 consists of three 8-bit bidirectional input output ports, and we call it as port A, port B and port C. And we can assign different ports as input or output functions. And not only that, since each port is having 8 bits, then obviously 24 input output lines can be configured as per the requirement of our system. That is the advantage. So 24 input output lines, that means 24 input output devices can be connected as per the requirement. Now let us see the pin description of 8255. 8255 is contained in a 40 pin package. So this is the pin diagram of 8255 PPI. As we have seen, the 8255 can be connected to the kind of devices. So generally it will be connected to the kind of character devices or the analog to digital or digital to analog converters. And it is going to contain 3 different ports. In each port is having 8 bits. So obviously 24 input output lines can be configured. Now this pin diagram shows it has 40 pins arranged in this kind of rectangular interface, and as usual we have the read write signal, chip select signal, ground and power signals, data lines are there, reset lines are there, apart from 3 ports: port A, port B and port C. This is how it has been designed. So let us see what are the names used for each and every pin. We have the reset input. This is the reset input. Chip select line, Then we have read input and write input, read input and the write input. Then we have port addresses A0 and A1. A0 and A1 are the port address which is used for selecting the ports. Then we have 3 port lines, 3 8-bit bidirectional ports, port A, port B and port C. So port A is having 8 bits ranging from 0 to 7. Port B is also having 8 bits ranging from 0 to 7. And port C 0 to 7. Then we have data lines, 8-bit data lines connected to the system bus. Then 1 pin for the voltage, or you call it as power line. Then we have a ground signal also. So these are the 40 pins that are available in 8255. So let us see the description of each and every pin. The data bus D0 to D7, these are the 8-bit bidirectional buses. It is connected to 8085 or any Intel microprocessor data bus for transferring the data. And then we have the chip select line. This is an active low signal. When it is low, then the data will be transferred. So that means only when the chip select line is having the low value, that is 0 value, the chip will be enabled for the data transfer. Then we have the read signal and the write signal. The read signal is again active low signal. So when it is low, read operation will be performed, and when the write signal is low, the write operation will be performed or will be initiated. Then we have the address lines A0, A1, A0, A1, these two lines, right? So these two lines are used to select any one of the ports, right? So these are the lines that will specify which particular port has been selected for the data transfer. So if these two lines are having value 0, 0, then port A will be selected. If it is 0, 1, port B will be selected. If it is 1, 0, port C will be selected. And if it is 1, 1, the control register will be selected for the data transfer. Right? So these lines will specify which port or whether it is control register is selected for the data transfer. Then we have the reset line, and the reset line is used to reset the device. So resetting means what? We want to clear all the data in the control registers. The control registers are the one which will specify what kind of operation is to be performed, whether it is input operation, output operation, whether it wants to read the status of the input output device. All these commands will be generally stored in the control register. So earlier the control register might have got some kind of commands which are to be cleared. For clearing, we are going to use the reset pin. So if this pin is activated, it will reset the device. Then we have the 3 lines, the port lines, the 3 different port lines, port A0 to port A7 and port B0 to port B7. And these two are again 8-bit bidirectional input-output pins which are used to send the data to the peripheral or to receive the data from the peripheral devices. So if the data is to be transferred to and fro from in the peripheral devices, then we can make use of port A or port B pins. Both are 8-bit pins. Then we have another port PC0 to PC7. This is also a 8-bit bidirectional input-output pin. But these lines are divided into 2 groups. How they are divided? They are divided into 2 4-bit ports PC0 to PC3 are the lower groups and PC4 to PC7 are the higher groups, right? So these are the two 4-bit ports, and these 4-bit port will contain a 4-bit latch, and this can be used for the control signal outputs and the status signal inputs in conjunction with port A and port B. So these ports are used in along with port A and port B, whether it is used for the control signal outputs, whether the control signals are to be generated or the status signals are to be read from the devices. So for which it will be used as a 4-bit latch, and this will be working along with port A and port B. So whether it has to read the status signals or whether it has to generate the control signals, that will be decided by these two 4-bit ports, right? So these are the different pins available in 8255 PPI, and the pin description also we have seen very briefly what are the different pins available and what is the description given for each and every pin. So in the next video we will be discussing the functional block diagram of 8255. Thank you.